Now, guys, hello, and I hope everyone is well. I'm going to look quickly at question 8 and 10 that I got for homework yesterday, page 345, 346, and then in another separate video, I will go on to expected value, the last part of probability that we have to cover, and I'll be talking to you live then tomorrow. Okay, so here's question 8. I've cut it out there and I brought it down here so I can do the work down here. A student enters a spelling competition and reaches the final. The final consists of 3 rounds. In each round, he is asked to spell a word correctly. If he spells all 3 words correctly, he wins. If he misspells any word, he will be knocked out. So basically, it's again one of these Bernoulli things. Gotta succeed or fail. The only way to succeed is to get all 3 spellings correct. Otherwise, even one wrong and he's out. He calculates that on average, the probability of him misspelling a word is 0.09, so 9% basically chance of misspelling a word. So that would lead you to believe he has a 91% chance of spelling it correctly. What is the probability written as a percentage to the nearest whole number? What is the probability written that he, number 1? So I suppose I'm going to, even before I do that, I'm just going to write that probability of incorrect spelling is 0.09. Okay, so 9%. Probability of correct spelling is therefore 0.91. It must be. Okay. Now, what's the probability written as a percentage that he gets knocked out of the final on the second round? On the second round, well, that must mean probability that he gets knocked out on the second round. So that must mean that he got correct on the first round. So, and then got it wrong in the second round. So got it correct on the first round. So that must be 0.91. And means multiply. Got it wrong in the second because he got knocked out. Okay. So that's what they're looking for there. That is 0.0819. And multiply that by 100, and that'll give you, so if we multiply that by 100, does it say to the nearest whole number? It does, to the nearest whole number. So if we multiply that number there by 100, we get 8% to the nearest whole, okay? 8%. So there's an 8% chance here that this guy will get knocked out on the second round, okay? Part 2. What's the probability to as a percentage to the nearest whole number that he gets knocked out of the final on the third round? So it means he got it right on the first spelling correct, and second spelling correct, and third spelling wrong. Okay, multiplying out all of those, we get 0.0745. Change that to percentage by multiplying by 100 and then getting it to the nearest whole number, 7%. So there's a 7%. There's a bigger chance actually that he will be knocked out in the second round. Yeah, just about 1% difference. And the last bit, he wins the spelling competition. Okay, so what's the chances that this guy wins the spell? So gets the first spelling right, and gets the second spelling right, and gets the third spelling right. Okay, that all works out as 0. When you multiply it out, 0.7536. Change that to a percentage to the nearest whole number. So we multiply by 100, we get 75%. So he's a 75% chance of winning, getting 3 spellings correct in a row. Okay. Very good. As with all these questions, guys, it's all good and well me doing these here on my device and sending them on to you. But look, I know how to do this stuff. Obviously, you guys, are learning. And if you're not too sure, you need to let me know. Okay, you need to get onto me, email me. Some of you are great at emailing me, or get me on Teams. Whichever way you can get me, get me. Now, question 10. The probability that Liam will be on time for school on any given day is 0.85 or 85%. What is the probability he'll be late for school? Well, sure, that must be 0.85 1.5 then, if that's the case. Okay, so let's go do it over here. So probability of being, was it on time? Probability that we be on time. That's what they tell us, okay? 85% chance of being on time. The probability of being late then. That's what they asked in the first question. Part A, part 1. So if he's, chance of him being on time is 0.85, well, the chances of him being late then must be 0.15. Remember, these two numbers should add to give you 1. Okay. Now, or 15% if we were to do it as a percent. Part 2. What do they ask us? Did it up a bit? What's the probability? Why is the probability that Liam will be late for the first time on the second of 2 days? So that means that he was on time the first day and late the second day. Okay, so that works out as 0.1275. Okay, or about just over 12%. Part 3. Part 3. The third. So what will be the probability that Liam will be late for the first time on the third of the 3 days? So on the third. So he was on time first day, on time second day, late third day. Okay, we multiply out those and we get 0.1083. Okay, I'm kind of rounding off there. So, you know, just over 10% basically. Okay. Now part B. That was part A. I think I'll do part B over here. Let's just divide this out a little bit. Instead of going down, I'm just going to go across here and do B over here. Now, what's the part B? To the nearest percent, what is the probability that Liam will be late exactly once over the 3 days? So exactly once over the 3 days. So he could be, yeah. So how many ways could this happen? Okay, let's write down. Now there's a few ways you can do this, okay, but I'll organize it this way. So let's just say that L means late and T means on time, okay? You can do whatever way you want. So we need to figure out the probability of him being on time, or let's go late. Actually, let's just say late first day. So late exactly once, and let's say it happens on the first day. Late, then on time, then on time. Or, remember, or means to add the probability of him being on time the first day, but late the second day, and on time the third day. Or the probability of him being on time the first day, on time the second day, but then late on the third day. So if we work out each one of these individually, so this, then this, then this, and then add them together, that'll do the trick. So okay, let's work this out then. The probability of being late, remember, is 0.15, and means multiply. Being on time the second day and being on time the third day. Okay, plus, now we're on to this bit now. What about the probability of being on time the first day? Is that, and, so and means multiply. Okay, so and means multiply. Late on the second day and on time the third day. Okay. Plus, finally, now we're just going to do this bit. So what about being on time the first day? So that's the percentage chance of that, or the decimal chance of that. And on time the second day. And late the third day. Okay. So as always, do it inside the brackets first. Now you multiply 0.15, multiply by 0.85, multiply by 0.85. It's actually the same sum we're doing for all of them. So once we multiply out the first bracket there, we get 0.108 375. Okay, and you multiply out the second bracket, you actually get the same number. And you multiply out the third bracket, and again, you get the same number because you're multiplying the same numbers together, so you get the same answers. Then it's all a matter of just adding up all of those, and this is what you get. So did they ask us to do it as a percent, I wonder? Let's go back. Whenever you think you have a question done, always just go back and just see, did I answer what they asked, okay? So you might think you're finished and you're on to the next one, but just always go back, have a look. To the nearest percent, it says. Okay, so we need to multiply that last number there by 100. Multiply that by 100 and to the nearest percent, so approximately, so instead of an equal sign, we do this for approximately, it works out 33%. So the percentage chance of him being late one day out of the 3 is 33%. Okay, guys, hope that makes sense. Like I said earlier, let me know if it doesn't, just get on to me, okay? Another video coming up now explaining what expected value is, and that's the last thing in this chapter then.